Yeah, sorry for interruption. Let me wait to see whether you guys are on. Declare that you are on for me to proceed. I don't want to leave you because this is a new concept. Yeah, there was a hiccup again, but declare that you are back. Declare that you are back. Declare that you are back and we proceed. I don't want to leave anyone here. This is a new concept. Yes. Declare that you are back, James. Any other? Before we proceed. Meanwhile, I'll be studying what I am live streaming. Be looking at how we have been moving before we come to the conclusion. We are coming to the end of that expression. We are coming to the end of that expression shortly, and then we shall see how we can use it on other expressions. We are saying slowly but steadily we have been able to come to this. Now, what we normally do is we let 2x to be equal to theta. If we let 2x to be equal to theta, this implies that actually x is theta over 2. I repeat. Kindly declare that you are back fully. I can see two people, but I am not seeing the other one identifying. Identify yourselves. You know how to do that. Good. So we want to wind up with the operation of this part, the first part, and then look at how we can use it on other parts to come up with a T formula. At this stage here, we let, like I have just written here, 2x to be theta. That implies that x becomes theta half. Are we together? So if I substitute in as said, I'll write this as theta, the sign of theta will now become 2 the tan of theta half, because this is x, over 1 plus the tan squared of theta half. And for the T formula, we say if T is equal to tan of a half theta, then this will now give us an expression that we shall say is 2t out of 1 plus t squared. Take note of that. Just as beautiful as that. That if we consider 2x as theta, and therefore from here x becomes theta out of 2 when we make it the subject, we can rewrite this and say it is now the sine of theta is equal to 2 times the tan of theta half over 1 plus the tan squared of theta half. Now if we further let tan theta half to be represented by t, we come up with the T formula for sine theta. We come up with the T formula for sine theta. We can prove the T formula for cos. The T formula for cos. We can derive. It is like derive. Remember we started up there. We also have it up there. That cos of 2x is cos squared minus sine squared x. For this one, the beauty here is that we assume that we divide by 1. Divide this by 1. I am not going to divide by 1 here, it will stay the same, but ideally that is it. If I divide by 1, I'll write my next step as, remember from first identity, that cos squared. So this one is now going to be filled in by that. That it is that minus sine squared x now over cos squared x plus sine squared x. That seemingly 1 is miraculous that you can replace it with that. Well aware as mathematicians now that we know that this is 1, the denominator. So we go ahead and divide the next step. Divide each term. Let me use this. I hope you all know that this means each, much as it also means at. Divide each term by cos. Our target is to make sure we bring in the tan. And we do that on the left hand side. So our cos of 2x will therefore become, I will write it there to avoid missing. Each of these terms is divided by cos squared x, up and down. And because we are dividing through by a common term, we have not changed the expression still. Because that cos squared x, we have divided it up and down. So it can cancel out if we so wish. In other words, we are still at the same step as the previous one. But we go ahead and incorporate it in. If I incorporate it in and I put it here before I move to the next page, you will agree with me that this will be 1 here, and this will be minus tan squared x over 1 plus tan squared x. It simplifies to simply that. I'll move to the next page. That means I'm picking cos of 2x is equal to now this. So my cos of 2x is now equivalent to 1 minus tan squared of x over 1 plus tan squared of x. Again, if we are here, remember that our 2x is equal to theta. If our 2x is equal to theta, again, our x is theta out of. So we substitute for both. This will give me cos of theta now. We are almost at the end. Tan theta squared theta out of 2 over 1 plus tan squared. We just press the x there, theta out of 2. But we already said that tan theta out of 2 is t. So we simply replace back our tan with a t. We have 1 minus t squared over 1 plus t squared. This is the t formula for cos. The other one was the t formula for sine. We obtained that. In the same reasoning, I don't want to leave these as exercises. You find their exercises in backups. I don't want to leave them as exercises. We can also find the t formula for tan. T formula for tan. And I want you guys to master these proofs. These ones come as proofs in an exam. We are deriving them from the double angle. The tan of 2 theta we know is 2, the tan of theta out of 1 minus the tan squared theta. Now for this one, it is direct. There are 2 ways. I will show you both ways. Here we already know that 2 theta is x. Now we know that 2 theta is x. 2 theta is x is what? X is equal to x is equal to 2x is equal to theta. We know that 2x is equal to theta. So it implies that when they talk about 2 theta, it is the same as what? The tan of 2 theta is this. And for the previous one, I've been saying that 2x is equal to theta. But this time I have used tan of 2 theta straight away for a double angle. I would have used the 2x. I've been using x. Let me use x, not to confuse you. We start from x, and this is our x. For this, it is straightforward. You see, when you use theta, you can get confused. So if you use x and you know that 2x is theta, again, x will be theta out of 2. So this one is straight away going to give us the tan of theta. If we say that 2x is theta, and it is going to be equal to 2, the tan of theta out of 2 over 1 minus tan squared theta out of 2. But we know that t is the same as tan theta out of 2. And this tan theta will therefore be equal to 2t out of 1 minus t squared. For it, because it is already in tan, we simply do the conversions here and we substitute in and we are there. But the other alternative that I told you can be used here for tan theta specifically is that tan theta is the same as sin theta over cos theta. And we have already got the expression for sin theta as 2t over 1 plus t squared. And we have also got cos theta as 1 minus t squared over 1 plus t squared. So we can substitute direct for sine and cos as 2 out of 1 plus t squared divided by 1 minus t squared out of 1 plus t squared. If we do the mathematics, we get 2. This is 2t. 2t out of 1 plus t times the reciprocal. It turns upside down. This cancels, giving us therefore that the tan of theta is 2t out of 1 minus t squared as previously obtained. So for tan theta, it is easy to get since you are already playing around with the previous two which you have got, or you can also do it directly from this step here. For these two, cos and tan, the Backhouse book will always challenge you to take them as assignments, but we have worked through them. Now, I want to do one example in the interest of time. I've taken you through many numbers. I want to do one example that in exercise 17D. Exercise 17D. Exercise 17D. There are several methods that can be used, but there are questions here. They say, use the T formula. Let me do just one example and you try out these. Use the T formula to solve. And they give you to solve for values of theta within this range. And they give you a number like 7 cos of theta plus the sine of theta minus 5 is equal to 0. And they say use the T formula. This means know that cos of t is 1 minus t squared over 1 plus t squared. Then you should know that sine of t is 2t over 1 plus t squared. So if they are saying use the formula, and also tan of t is 2t over 1 minus t squared. If you are using the T formula, it means you are substituting here. So we shall have 7 into 1 minus t squared over 1 plus t squared plus 2t over 1 plus t squared is minus 5 is equal to 0. Now, to be able to solve this, we rearrange it into a quadratic equation. So we shall have 7 minus 7t squared plus 2t minus 5 into 1 plus t squared is equal to 0. In other words, there would be an LCM here. Okay, let me put it there so that you say, where did it disappear? There are students who find this work online. There are students who find this work online because this work is permanently going to be online, and it will also at a later time be accessible on YouTube. To like or to subscribe to the Let's Learn from home page already on Facebook. When I open fully the YouTube account, which is already open, if I finish uploading everything, I will let you know the account name, but it is already there. Now, we rearrange by opening. We shall get 7 minus 7t squared plus 2t. Here now, this now requires consistency and steadiness. Will now be equal to 0. In quadratic format, I am going to take everything to the right hand side because this 5 and this 7 will give us 12t squared. If I take it to the right hand side, it becomes positive. So do not ask that why are you now making it positive and you are seemingly keeping it on the left. I have crossed it the other side. Minus, the 2t will become a minus, and then 7 minus 5 will be 2, which will also become a minus. And this will now be equal to 0. I will remove all these, since 2 is common, is a factor of 12, I'll stay with this as the equation now. And I believe you know how to solve quadratic equations. We need factors of 6 that we multiply to get negative 6 and we add to get negative 1. And quickly, these will be the factors. Your mathematics should enable you to get the factors. I will not tell you how I get them. I expect that the time we have had together here has sharpened you enough, in addition to, of course, the factorization knowledge you have and the one we have interacted with under the different topics we have already covered. So I feed them back in after baptizing them with a t, as you are aware. And I do the pairing. I pull out the most common factor for these ones, and I eventually come up with 3t plus 1 and 2t minus 1 is equal to 0. That implies that my t is negative a third or my t is a half. But remember that t is tan of theta half. That's what you should remember. Remember that t is equal to tan over half theta. You would wonder, how will we get the angle? So it means that tan theta half is negative a third, which implies that we can get values of theta as those values whose tan inverse is negative a third. Similarly, tan theta half is a half for the other part, implying that we need values of theta whose inverse of tan a half is. Ensuring that your calculators are in degrees mode, we can look for these angles. I'll start with this one and get my theta values. The range is 0 to 360. Since this is a negative, it tells you that it is here and there. It tells you it is in the second and the fourth quadrant for this one. So we get the first angle, negative a third, and the first angle is negative 18.43 degrees. This is the only example I'm going to do for today, and I will ask you to use it for now to do the other numbers. There is another method which we shall discuss probably tomorrow. So if we get this as the angle, this is the angle here. It is negative. Negative angles, we said they are measured in the clockwise direction. So if we add 360 on it, it gives us the actual angle in that very quadrant, which is, we keep this one there because we have not concluded. So we get 341 point, we can say 0.6 degrees. That is the angle in this quadrant, but there is another angle in this quadrant which will be 180 less by that. If we get that first angle, we go to 18.43, and we take it away from 180, we should get another angle of 161.6 degrees. The tan of that angle should also be giving us our negative a third. So these two angles, this one and this one, qualify for this first part. We look for theta here, arctan over half. A half is positive. That means we expect it to be in the first quadrant and in the actual tan quadrant. Shift tan inverse of 0.5. And the first angle we get is 26.57 degrees. This is in this quadrant. And we add it on 180. We add it on 180 to get to the next angle, which should be 206.60 degrees. These angles are the only angles in the range given. So the values of theta, as we conclude in ascending order, will be 26.6 degrees. That is the first smallest angle. It will be followed by 161.6 degrees. Will be followed by 206.6 degrees, and will be followed by 341.6 degrees. These should be the values of theta in that range. This is question 3B, and that it is not in the exercise, but normally the book should provide answers for such questions. Those are the angles that question 3 should be able to have. Now, in the interest of time for the next lesson, I would want to encourage that you will try out the remaining numbers of that question 3, and also try out the numbers in exercise 17D. But for now, attempt to use the T formula. Do not use that formula that is discussed as the form of A cos B. There is this form of A cos B or cos theta plus B sin theta. We shall be discussing this tomorrow before we forget. So tomorrow we shall continue with this. But meanwhile, page 351, try out. I've done part B of question 3. This is question 3. I've done part B. This is part B. So you can try out the other parts, A, B, and C. A, B, and A, B, A, C. And study this other work. They are done examples. They are the ones we shall be discussing. Otherwise, for now, I sign out and wish you a good day. And you are aware that we shall be discussing your findings among these exercises and the previous ones, especially where you have challenges, as a continuation follow-up in both areas. It will be a mixed discussion. Follow the time range I gave you on our platform. God bless you, and keep practicing. Don't forget.